Hello, my name is Muhammad JAUHAR bin IBRAHIM, with the matrix number 231291, and today I'd like to present understanding fluid properties and their engineering applications. Fluid is a material that continuously deforms under shear stress that includes both gases and also liquid. Engineers rely on fluid properties for transport, energy transfer, and control system. Today I've chosen three properties, which is viscosity, density, and compressibility, to talk to you about. Each properties influence system design and operation differently. Understanding this is essential to solve engineering challenges and optimizes process. Firstly, viscosity. Viscosity used to measure internal fluid resistance to flow. It affects pipeline pressure loss and pump selection, especially in crude oil transport. It is critical in mechanical systems like engines, and it determines lubricant performance of a material. Viscosity changes with temperature. It requires use of multi-grade lubricant. If you failure to account for viscosity can lead to overheating or system failure. This is to show the difference between viscosity of two materials. As we can see, honey take lower time to drop into the beaker than water because it is higher viscosity. Second, density. Density is defined as a mass per unit volume that is important for buoyancy and flow dynamics. It is used in submarine design to control submersion via ballast tanks based on Archimedes' principle. It is enable gravity-based separation in oil-water separators and also wastewater treatment. It is also central to mass transport and fluid layering in chemical processes. And finally, it is also vital for centrifugation and sedimentation and also decantation in refining industries. This density plays a huge role in our industry in engineering. Here we can see that the liquid density of multiple materials. The lower the density, the higher it will be on the beaker. The third and the final fluid property I like to talk to you about is compressibility. Compressibility describes how fluid volume changes under pressure significant in gases. It is crucial in aerospace. It affects shock waves and nozzle design at high speed, which is Mach 1, which is the speed of sound. It is also used in natural gas pipelines to predict flow and volume changes with pressure. Engineers apply isentropic flow equations and real gas laws to calculate compressibility. Poor compressibility management can lead to system instability and inefficiency, then can also cause to accidents such as explosions. Here is a picture that shows the compressibility of multiple gases. We can compress by applying pressure, but also it has its limitation for each material. I have also chosen an engineering issue, which is multi-phase pipeline transport. Multi-phase flows involve liquid, gas, and sometimes solid with conflicting properties. High viscosity increases energy demand, and density difference can cause flow separation. Gas compressibility leads to pressure volume instability, and also issues include hydrate formation, slugging, and also system shutdown. Engineers use pigging slug catcher, heating systems, and simulation tools such as CFD and Olga for flow assurance. Here we can see an example of a multi-phase pipeline transport. The solution for this issue of multi-phase pipeline transport is that we use simulation tools to help model real gas behavior, viscosity, and phase interaction. Temperature management reduces viscosity and controls compressibility effects. Mechanical components like compressor and heat exchangers are optimized via modeling, and operating limits are defined based on pressure, temperature, and phase behavior. Balancing all three properties ensures efficient, stable system operation. In conclusion, viscosity, density, and compressibility are foundational in fluid system design. Each affects a different aspect, which is flow resistance, buoyancy, and pressure response. Their interaction create complex design challenges, especially in multi-phase systems. Engineering solves this through modeling, system design, and adaptive operations. A strong grasp of fluid properties ensures safer, more sustainable engineering solution. These are the references that I use for this presentation. Thank you for watching.